What we're going to take a look at here is performing various operations on complex numbers. And really the main thing to look at, especially with addition and subtraction, you don't want to overcomplicate this. All we're really going through and doing is combining the like terms, with real numbers being one set of terms and then the imaginary numbers being the other set of terms. So really all we're going to go through and do is look at this as a number that's all being subtracted. So we're really subtracting 4, and we're going to go through and subtract 3i. So we can go through and just distribute that negative sign to both of these terms and eliminate the parentheses. Really the same thing over here. If we're adding 7, that's going to be just plus 7 here. And if we're adding negative 4i, that's really just like subtracting 4i. Now at this point it's combining all the like terms. Combine the real numbers. So negative 4 and positive 7 is going to give us positive 3. And then if we combine 2i minus 3i minus 4i, combining all of those, that's going to give us negative 5i. And looking at this is a complex number because it is in this format. It has one real part and it has an imaginary part as well. Now when we look at division, what we need to do is we incorporate what's called the complex conjugate. What a complex conjugate is given number a plus bi, its conjugate, the a and the bi are going to be the same exact numbers, but the sign in the middle changes. It becomes negative, or if it were negative it would become positive. The reason why we do this is if we multiply these two numbers together, your answer is going to end up being a real number, which is what we want here, because looking at this, we're trying to eliminate the imaginary number in the denominator. So we're going to go through, multiply by the complex conjugate of the denominator. In this case, it would be 4 plus 3i. Alright, when we go through, you'll see these will, when multiplied together, will come out to be a real number. And what I do to the bottom, I'm going to end up going through and doing to the top as well. Because all this will really come out to, I'm going to go through, distribute the 4 to both, distribute the 3i to both, go through the same process here, distribute the 7, distribute the 2i. On the top, what I come out to is 28 plus 21i plus 8i plus 6i squared, all that being over 16 plus 12i minus 12i minus 9i squared. And now from here I'm going to go through, combine the like terms, and I'm going to use the fact that I squared is equal to negative 1. And we know that because by definition I is equal to the square root of negative 1. So we're going to use this because we don't have an I squared in a complex number. All we have is an I. So we want to eliminate these terms as well. I'm going to combine a few things at once. We'll combine the 21 and the 8i. This is 29i. In this step, we plug in the negative 1 there. For that I squared, and we're going to go through the same thing on the bottom. So these two terms we see are going to cancel one another out. So all we're left with is 16 minus 9 times negative 1. Okay, and we can go through, simplify these a little bit more. We're going to have 28 plus 29i minus 6, all of that being over 16 plus 9. And then combine the like terms, combine our like terms, we would have 22 plus 29i, all over 25. Now from here, to kind of finish it all off, we're going to put it into that complex number form where we're going to just split the fractions here. And remember, really what this is saying is we're dividing the first piece by 25, and then we divide the second piece by 25 as well. So how we'll actually write this, 22 over 25 plus 29 over 25. I running out of space there. Just fit it in. Alright, and now at this point, if we could, we would reduce these fractions, but 22 over 25 and 29 over 25 we can't reduce. So this would be our final answer, and if we look at it, that's in the format that we looked at up here, a plus bi. And that's what we wanted for our final answer.